I've had a really tough day. I have just been spent most of it manually provisioning infrastructure on my cloud provider, creating resources, deleting resources, recreating them. I think I've got a bit of RSI. If only there was a way you could represent infrastructure as code and then automatically deploy it via maybe a CI/CD pipeline or something like that. That would be a utopia to me. If only such a thing existed. Wait a minute. Such a thing does exist. And in the video coming up, I'm going to show you exactly how to do all of that. So stay tuned. Well, hello, wherever you are, whenever you are. Where am I? I'm in Melbourne, Australia, and when is it? It's May 2020. Well, I hope you enjoyed that dramatic reimagining at the start of the video there. I genuinely think I'm wasted here. I should have become an actor, and maybe with a performance like that, I would have won many, many Oscars. I don't know. What do you think? Comments below. Maybe don't. Anyway, it's great to have you back, great to have you with me. We've got quite a lot to get through, so I'm going to jump straight into it. Before we do though, just if you like the video, it's maybe a bit early to make that judgment call, but if you like the video, please do give it a like, and if you haven't done so already, please subscribe. And to my wonderful Patreon supporters who just go that little bit extra by way of support, thank you so much to you too, and of course your names will be appearing at the end of the video. But for now, let's take a look at what we're going to be doing. All right, yes, so today it's a Azure DevOps special, and we're actually going to be provisioning API infrastructure using something called Terraform, and we'll be building a fully automated CI/CD pipeline all the way through from coding right the way through to not just deployment, but actually provisioning cloud infrastructure as well. So this is what you're going to learn in today's course. Now what I'll say is this is quite a long video again. In the description below you can actually jump to any of the parts of the video I'm going to go through now if you want to just go straight to a specific section of interest. I would recommend you watch the whole video, but if you just want to go to a specific point, you can do that. And it also means you can revisit the video and come back to specific bits if you want. So yes, in the description below, take a look. I've got the full outline of the course. But yes, what we're going to go through, I'll give you an overview of today's tutorial or today's course. I'll take you through shortly what we're going to build. We'll talk briefly about the value of infrastructure as code, and then I'll take you through what tools you'll need to work with today's course. We are then going to move into our course, and we're going to scaffold up our API using .NET Core. We're going to package that with Docker. We're going to push it to Docker Hub, and we're going to push our code to GitHub. Now, I've covered a lot of this stuff before in my previous videos. I'm going to go through all step by step. I'm not going to skip, but I'm not going to dwell on it, okay? So if you're not used Docker before, you're not that familiar with APIs, check out some of my other content and then come back here. Otherwise, we are still covering it all completely step by step. Don't worry about that. And what we'll say is the code is going to be on GitHub, so I'll put that in the description text below as well. So if you want to look at the code as you work your way through the video, it's all there for you as well. So once we've done that, we're then going to move on to talk about Terraform, which is kind of the central concept of today's video, along with Azure DevOps. And we'll talk about the benefits of Terraform, what it is, why you would use it. We'll write our first infrastructure as code file. We'll provision that on Azure, and then we'll talk about some security considerations. And we'll be doing all that at our command line just to get ourselves set up for what comes next, which is moving over to Azure DevOps and creating a fully automated CI/CD pipeline. So yes, we'll set up a project. We'll set up some service connections, which is basically the connections to the other systems Azure DevOps needs to talk to. We'll set up our pipeline, and we will trigger our first build all the way up from our desktop to kick off the pipeline. Into Azure DevOps Part 2, we'll talk about something called variable sets. We'll introduce Terraform into our pipeline, and we'll talk a bit about Terraform State. And yes, we will add Terraform to our pipeline and run it. We'll talk about something called Idempotency, and It's not an issue, but something we need to cover off, and we'll also talk about build versioning, which is very important too. And then finally, we will wrap up. Yes, I'm going to give you homework, you heard correctly, and a bit of wrap up and my supporter credits to round it off. Cool, so I think I've mentioned everything I've wanted to there. Yes, chapter links are below, and also our code is on GitHub as well, so you can follow along. Awesome, so let's talk about what we're going to build today. Now, you will see here, you've probably seen something like this before when we're talking about DevOps. I've kind of repurposed it for my own purposes. And the one thing I want to just call out straight away, you would usually have a testing step in your DevOps pipeline. It's one of the most important parts of it. For this video though, it's not the focus, and I felt adding in unit testing and all that kind of stuff isn't really going to add benefit to today's central topic. So I've taken that out of our pipeline, but just be aware, of course, best practice is that you would always have a testing step in your pipeline. So we will start off with down on our desktop using VS Code, where we will scaffold up our API code. We will have our Docker file that will take that code and make an image, a Docker image from it. We will write our first Terraform as infrastructure as code file that will specify the resources that we want to provision on Azure. And we will have our Azure pipelines file in our project as well, which describes how our pipeline should operate and run. Now, a really important takeaway from today's video is that is all considered as code, a unit of code that we will commit to GitHub. Now, you'll notice that we have our application code in there, we have our infrastructure as code in there, we have our Azure pipelines code in there, all considered code. And I guess where I'm going with that is, as an application developer, sometimes you forget about infrastructure. As an operations person or an infrastructure person, you might not be that involved with the application code. With this approach, you're basically bringing the two worlds together, true DevOps, into the one place and getting them to think about each other's domain, and really, breaking down and dissolving those boundaries where you no longer have dev and ops, where it's really just a DevOps team. So, very important concept. Our code is considered as one unit that we will push up to GitHub. GitHub will then trigger our build on Azure DevOps. And what we're then going to do, Azure DevOps is going to build our Docker image. It's then going to push our Docker image up to Docker Hub. And then it's going to use Terraform, and we'll come on to what Terraform is in a bit, to provision and deploy that image out to Azure. And Terraform is going to do that in conjunction with Azure DevOps, where it will talk to Azure and provision our resources for us. And that is going to be completely automated. The only manual step in that, at the end of the day, is going to be the push up to GitHub. So you're going to build all that today. You're going to use all these tools today, fully step by step. But just before we move on, the main thrust of today's video is around Terraform, is around Azure DevOps and Azure and the provisioning of infrastructure and those two files there specifically. So while we cover everything else, it's not a deep dive, so just be aware of that. All right, so just very quickly, some benefits of infrastructure as code. As I kind of said there, it truly brings dev and ops together up front, and I would consider it a DevOps best practice. You'll end up with consistent infrastructure configurations rather than stuff that's maybe somewhat ad hoc. You'll end up, of course, certainly with faster deployments, and I can certainly attest to that. Even if you're not deploying stuff or provisioning stuff in production, even if you're just setting up test environments or dev environments, I can tell you using this is so much quicker than manually having to set stuff up. So you definitely save a lot of time. There's less documentation because code effectively replaces it. And you have that traceability because you're checking your code into a repository, it's fully traceable. And you're not going to end up with instances where you have critical bits of server infrastructure sitting under people's desks and nobody knows why they got there or how they got there. And I'm not joking, that happens. Even in some of the largest companies out there, that happens, which is truly shocking. So infrastructure as code gets rid of all that and you have real traceability where everything comes from. Cool. Finally, our ingredients before we move on to starting the course. Text editor, I highly recommend VS Code. It's free. .NET Core SDK, which is free. You can swap out that for another framework if you want. It's not really wedded to that, but there will be some differences in the rest of the project. So if you want to follow along, I really suggest you use .NET Core. Terraform, which is free, Azure CLI, which is free, Docker, which is free, and then you'll need accounts on Azure, Azure DevOps, GitHub, and Docker Hub. All of those are free, with the exception of Azure, where you will need to supply a credit card if you want to sign up. But if you've not signed up to Azure, you'll get a 12 months worth of free services, and the services we're using today, I'm fairly confident, are included within that free remit. Even if they weren't, they are very, very low impact from a cost perspective. So, you know, tear this stuff down once you've finished with it. It's going to cost you pennies or cents or whatever currency you're using. So not going to be expensive, but yes, you will need to provide a credit card on Azure. Everything else completely free and you just sign up. Cool. So let's get coding. Oh, let's get coding our infrastructure. What are we waiting for? Okay, so the first thing we want to do is create our very simple API that we'll use throughout the rest of the project. So let's open a new Visual Studio Code window. I'll bring that over onto the screen. Control apostrophe just to bring up a shell, and I'm going to move into my working directory, which is on my D drive. So I'll change into season 3 and change into episode 3, where we are now. First thing we'll do is a .NET version, just to make sure we have the .NET SDK, .NET Core SDK installed, and indeed we do at version 3.1. If you get an error message there, just Google .NET Core SDK and follow the instructions to download. Awesome. So the next thing we want to do is get a list of the potential templates that we can use to create our project, and that's .NET New, and that gives us a list of templated projects that we can scaffold up, and the one that we want is this one here, the ASP.NET Core Web API, and that's called Web API. Now this isn't a tutorial on Web APIs, I've done plenty on that already, so if you're not that familiar with them, please check those out. Otherwise, let's get cracking and set it up. So again, .NET New, Web API, we'll give it a name of Weather API, for reasons that will become very obvious in a second. And that should create our project folder. So let's open that in VS Code. So code R to open it recursively, Weather API, and that will just reopen the project in Visual Studio Code. Perfect. Now we'll get a little pop-up here, I'm sure, in a few minutes or a few seconds. Just click yes, you only have to do that once. And this is our project. Again, not going to go through it in massive detail. What I am going to do, and this is the only bit of, it's not even really coding that we're going to do at this point, is click on our startup class, and I'm going to remove this HTTP redirection command here. I don't want that at this point in time, so take that out. If you don't, it's probably okay, but I would take out anyway just to be on the safe side, just to keep things nice and simple. And that's basically it for the coding. Let's just test that it runs. I mean, it should run. I'd be very surprised if it didn't, and I can show you what it does. So .NET Run, that will run it up. Let's bring a web browser over here. And I've probably got it cached already from when I've been playing before. So yes, localhost, port 5000, and then we want to hit the weather forecast controller. And indeed we have, and it just brings back some JSON data that represents some weather information. This is somewhat randomized, so if we run it again, it'll bring back a slightly different view. I think that's different. And that's it. That's all we need to. We're going to deploy that out to Azure. We don't need to do any more with it. We might make some minor changes just to test our pipeline, but for now, that's all we need to do by way of the code in our project. But what we do need to move on to now, because we're using Docker, is to add a Dockerfile into our project. Okay, so let's move back over to our application project. Let's kill the running web server, and yes, we want to create a Dockerfile. So right-click, click anywhere in the root of your project. You can either right-click New File or use the little icon up here. We're going to call this one Dockerfile, no surprises. And what is a Dockerfile? Well, it is just a set of instructions. It takes our application code and packages it into a Docker image that we can then run and publish elsewhere. Now, I never really usually like cutting and pasting code, but I'm going to do so in this instance as Docker and Docker files are not really the core thrust of what this video is about. If you are interested or you're not sure, you've not used Docker before, then I've made some other videos on that, and I also have a fairly detailed blog article that goes through how it works and what it does. So set of instructions, let's save it off and let's run it. And what that will do is it will take our code and create an image. Now, I strongly recommend, if you're using VS Code, to download or install this little extension, and it gives you a nice view of your images and your containers and all that stuff. So to build, Docker build, we use the Docker CLI, and we're going to tag our build with a name, and the convention is your Docker login ID, mine is binary thistle, and then / the name of your, whatever you want to call it, and then just the build context, which is our current working directory. And that will go off and build our Docker image. And you'll see some activity here where images are being pulled down as part of the build, all that kind of awesome stuff. Now, once we let that happen, I don't have any images, so that's why it's pulling those down. When that happens, we'll run it just to test it, to make sure it works. And then finally, we'll manually push it up to Docker Hub. So Docker Hub is basically an image repository where we can publish our own images and also download images from vendors such as MySQL, Oracle, and Postgres, and all these kind of people, and get their pre-packed images for use in our project. So very, very powerful, very useful. Now, we're doing this manually, but we are going to, of course, replicate this in an automated fashion in a bit. So that looks like that's worked. You can see here we now have 3 images, the 2 Microsoft ones we were referencing and our binary thistle weather API image. Let's just test it to make sure it runs, and the way that we run it is docker run. I'm going to do a bit of a port specification. I'm going to map to an external port, could be anything. I'm using 8080 and I'm mapping it to the internal port exposed by our image. And you can see here that was through this little declaration here in our Docker file. Cool, and then we just need to tell it what image we want to run. Make sure I spell it correctly. Binary thistle weather API, and that should just run it up. Fantastic. Now, if we pop over to here, previously it was running natively on our desktop on port 5000, so if we change it now to 8080, we should get a very similar output. And indeed we do, so that's cool. That's all working. Let's just kill that. You'll notice Control-C on Windows anyway doesn't stop it from running, so you can either right-click here if you're using this plugin and click stop, or Docker, to click into the terminal, Docker PS to get a list of running containers, and then Docker stop, and you can either use this ID or the name. Probably better to use the ID actually, because the name may not be unique. And that will stop. You can see that's stopped running. Cool. And then the last thing we want to do is publish it up to Docker Hub, just to, because we will be making use of it in a second. Docker push, and then binary thistle weather API. And that will then push our image up to Docker Hub. And we will make use of that in a minute when we come on to using Terraform at our command line. We will need that in our repository. Cool. Okay, so that has finally finished. And if we move back over to Docker Hub and do a bit of a refresh on my repositories, we should hopefully see weather API. Now, we've done this manually. We will be setting all this up automatically as we move through the video. Cool, so the next thing we want to do, we're going to add our project to GitHub, and therefore locally have it committed to Git as well. So just before we do any of that, I want to add a gitignore file to the root of our project. So new file .gitignore, and that just means we don't include a lot of stuff that we don't really want to include, mainly compiled assets and all that kind of stuff. Now, I'm just copying that over as well. I wouldn't even dream of typing that out. It'd be ridiculous. So copying it from another project, and this is again available on the article that I referenced previously, or you can just Google gitignore file, and there's some good examples out there. Cool, so that's that done. We then just want to initiate a local Git repository, so git init. And you can see we have some nice stuff that we need to add to our repository, so git add everything. Cool. And then we want to do a git commit, and we'll call this initial commit. And that will commit everything, and we do a git status. We should be all clean on our local branch. Fantastic. So what we want to then do is push all that up to GitHub. So let's get GitHub up and running. GitHub. And again, I've already logged in, so it takes me to my GitHub repository, and let's create a new repository to house all this. So new repository, and I'm going to call it season 03, episode 03, and we'll call it I don't know, Azure DevOps and Terraform. I'd be very doubtful if that existed elsewhere. We'll leave it as a public repository for now. I'm not going to bother giving it a description, so cool, click create. And you can see here, if we hadn't already created our local Git repository, we'd have to follow these steps, but we only have to do the following 2 steps here. So you can probably copy these lines in both at the same time. I prefer doing it one by one. I don't know why, I just do. And then I can remember the last command would be the git push origin master. And that'll take our local Git repository and I'll push it up to GitHub. Now this activity here is the activity that, again, going back to our PowerPoint, will trigger the whole build pipeline. Cool, so we move back over here and do a quick refresh. Let's just make sure that got popped up to GitHub, and indeed it does. Cool, so we've kind of done the groundwork that we need to get started with Terraform at our command line, so let's move on to that now. So actually, just before we move on to actually using Terraform, I thought it would be worth just spending a couple of minutes on just covering what it is exactly, and more importantly, why we're deciding to use it in this case. So on screen, you can see along the bottom, I've depicted 3 of the bigger cloud providers out there. The important takeaway is that Terraform will actually work not just with those 3, but with many, many other providers as well. But I just put these 3 on screen because I felt most people watching this video will have some degree of familiarity, I think, with one of these 3 bigger players. So what is Terraform? Well, before we answer that question, let's just talk about automatically provisioning resources on your chosen cloud provider. Now in my case, I'm more familiar with Azure. Now if I wanted to do that, don't need to use Terraform. I could just use Azure resource management templates, for example, to do that, a Microsoft specific technology to provision those resources, and that's okay, that would work. However, if I then needed to move everything onto AWS or Google Cloud, I would then have to learn their specific version of whatever it is, and I don't really use those clouds, so I don't know what they would be, but I'm fairly certain there would have to be some major learning involved in order for me to switch my delivery pipeline over to one of those providers, okay? So in the interest of saving time, this is where something like Terraform will add value and come in really useful, because it provides this layer of abstraction away from specific implementational detail and allows you to specify your infrastructure as code using its framework, using a common framework. Now, the way we define infrastructure as code in Terraform is using something called HCL, HashiCorp language, or you can actually use JSON as well. The HCL approach is the preferred approach. Nonetheless, you only have to learn that one framework, write your infrastructure as code in that way, and Terraform will then take care of the heavy lifting and provision across whatever cloud providers you need to use. So what it means for me as a developer then is, if I then do need to pivot away to some other cloud provider, yes, I'll have to rewrite my infrastructure as code definitions to a certain degree. You'll still have to understand some of the nuances with specific cloud providers, but generally speaking, the resistance to move is going to be greatly reduced. The other benefit it introduces, you might actually be an organization that uses many cloud providers at the same time. I know a number of organizations do that. And so again, Terraform provides this layer of abstraction so you don't have to deal with specifics. So that's really the benefit. That's why I really wanted to labour that point rather than just using technology for the sake of it. That is the benefit that it brings to the table for me as a developer. Future roadmap, future proofing, ease of movement, all that stuff. How does it work? Well, it makes use of the respective cloud providers API, and it makes use of its own providers that will talk to those APIs, as you can see there on screen. And so basically it will translate the definition files that you write in HCL or JSON, and it will translate them and make it into a format that is usable by the respective APIs for each provider, thus provisioning the resources as required. Cool. And yes, it works with further clouds. I just want to labour that point as well. So I think we've got a couple of other points. I think I've covered them all before we actually move on to using it. So yes, it's open source, so it's free, which is cool. Almost any infrastructure type can be represented. So what do I mean by that? I mean things like virtual machines, containers, databases, switches, all that stuff. So it can do all that. Covered this already, works with all major cloud providers using its own providers that talk to their APIs. And yes, we can express Terraform infrastructure code as HCL, which is HashiCorp language, and that is the preferred approach. Or you can actually write it in JSON as well. Now there's a number of other things we will cover off around the product as we move through the video, but I think it's time to actually get on and using it. All right, so we want to actually start using Terraform now. So in order to use it, we have to, first of all, download and install it. Now, we don't even really install it, to be honest with you. If you just Google Terraform download, you'll select your environment, Windows or Linux or OS X or whatever it happens to be, and in all cases it just comes as a single executable file, that's all. And if you want to make use of it from your command line more globally, then you'll have to update your environment variables, your path variable. In the case of Windows, I think it's probably the same on Linux. So just to show you environment variables, over here in my system variables, I've updated my path just to include the path to the Terraform executable. Cool. And if you're not too sure about how to do that, just Google it. I'm not going to show you how to do that here. It's pretty straightforward. And just to check that it works, type in Terraform at the command line and you'll get some advice on how to use it. Excuse me. And the other thing that you will need to follow along is the Azure CLI. So again, there are a number of different ways you can actually use Azure from your command line, but I advise you use Azure CLI. And you can see here that you can just get it and install it for your various platforms as well. Definitely recommend that that's what you use. It's much more straightforward than other methods, in my humble opinion. Okay, so I'm just going to clear down our work environment a little bit, and we're going to come on to actually creating our infrastructure as code file. So just before we go on, I'll just draw your attention to the fact that I have installed this Visual Studio Code plugin that allows some degree of auto-completion of the Terraform files that we're going to produce. There are other ones out there. I don't know if this one's the best one or whatever, but installed it, seems to work okay. Check it out, maybe look at some other ones that might work for you better. So to create our infrastructure as code file, we're going to create a file in our root. So new file, call it anything you like, but convention dictates we call it main, and then the extension has to be a .tf. And you can see very helpfully Visual Studio Code puts a little Terraform icon there for us. So the first thing we want to specify in our file is the provider that we are wanting to work with. In this case, it's Azure. So provider tag, and then the name of the provider, Azure RM. Open bracket, close bracket. Now this is this HCL language. It looks a little bit like JSON. It doesn't seem to employ the use of commas, which I don't actually have a problem with. It's quite nice. And this provider name is a Terraform name for its Azure provider. Again, all this is on the Terraform website if you want to understand the providers for different providers. So we need to specify a version that we want to use. And again, this is why I'm saying this particular plugin that's trying to autocomplete is not particularly great. It's not picking up that that's what we need to use, but you know, that's okay. And then the other thing we need to specify is this features tag. I thought I could get away with not supplying this, but it complains if you don't put it in. Cool, so all that's saying is we want to use Azure. Great. So the next thing we want to do is specify the resources that we want to create on Azure. Now, for those of you who've used Azure before, you will be familiar with resource groups. So before you can even create containers or virtual machines, you have to put them into a resource group. Now, I'm going to create one for our purposes. So you won't be surprised to hear that we define that by specifying this resource block, and we then specify the type of resource we want to create. So in our case, we want to create a Azure resource group. Now you're probably going, where did that come from? How do I know what these are? That's all documented on the website. So if you want to look, if you want to create specific type of resources, go to the website and look up the type that you'll have to specify here. And then we need to give it a name. Let's give it a name, Terraform test. Doesn't really matter what it's called. The only thing you need to bear in mind is that this name of this resource is the name in as far as this file is concerned. It's not actually the name of the resource on Azure that we are going to create. And these two bits of information taken in combination should be unique. And we can actually use these tags here to reference this from other resources. And you'll see what I mean in a minute when we come on to creating our next resource. Anyway, it's a good segue into saying we do need to actually name our resource on Azure. So we use this name attribute here, and it's just name equals whatever we choose to call it. So I'll call it Terraform main resource group. Doesn't really matter. And then we have to specify a location as well. And that is the location of where you want to provision your resource. And in my case, that's Australia East. Obviously, depending on where you are in the world, you'll probably want to provision it somewhere else, and you'll have to find out what that is. Just go to Azure and have a look at the available locations. You can actually do that from the Azure command line. In fact, let's not do that yet because I want to demonstrate something else, but I can show you that if I remember in a bit. Cool, so let's save our file. That's the first bit done, basically. So let's see if we can apply it to Azure. Now, the way you do that is by using the Terraform command line, and we're going to use a number of different commands over the course of this tutorial. Let me just show you what they are here. I'll have to remember to delete them. The first one is init, and that's going to basically initialize our Terraform system to make sure it's got the right provider to be able to talk to Azure. So we'll show you that in a second. Next command is plan, and that's more for us as a developer to see what Terraform has in mind, what it's actually going to do when you execute the plan. So running Terraform plan just generates a plan, doesn't actually execute the plan. And then the next command will be apply. As the name suggests, that's applying the plan, whatever that happens to be. And we will eventually use this command at some point. We have the destroy command, and I'm sure you can imagine what that does. So let's kick this off by doing terraform init. And you can see here it's initializing something called the backend, and we'll detail that a bit more when we come on to doing our pipeline. But for now, it's saying it's successfully been initialized and it's downloaded the plugin provider Azure RM. Fantastic. And you may have seen up here that we have this .terraform folder, and that's where that plugin now sits. Cool. So let's try and have a look at the plan. So see what happens. Now, actually, I wanted this to fail, to be honest with you, and it doesn't look like it's going to fail. It looks like it's going to work, and I'm going to tell you why in a minute. So I didn't want that to happen. So let's take a look at what it's done. It's gone off to Azure, and you're going to ask, how did it go off to Azure? But let me come back to that in a minute. It's gone off to Azure, and it's gone to check to see if we have a resource group called that, and I don't at the moment. So it comes up with this plan to say, Terraform will perform the following actions, and it's going to create the resource that we want. But I didn't actually want that to happen because I wanted it to fail. And the reason I wanted it to fail was you're going to say, well, hang on, can't anybody just run commands at a command prompt and start creating resources on my Azure subscription? How does that work? The reason that worked is I'm actually logged in to Azure using the Azure command line. So let's log out. Let's do that. And let's try it again. So this should fail now. Yeah, there we go, cool. That's what I wanted to happen initially. Try and run the plan. Terraform's going to go off to Azure and generate a plan. Of course it's failed because we've logged out. So it worked because I'd previously been logged in. So I just wanted to demonstrate that and put your mind at rest that Terraform doesn't have some specific privileges into your Azure account. So we need to log in, so we'll do it interactively at the command line. And that will, in this case, generate a pop-up here that will ask me to log into my Azure subscription. Now, cool. This is fine. That is fine for working at the command line and doing stuff interactively. But when we come on to implementing this in our pipeline, we of course don't want any degree of interactivity at all. We just want things to be authenticated through without that interaction. So we'll come on and I'll come on to showing you how to do that. And in fact, we'll set it up for our command line and then we can apply the same principle when we come to setting up for our pipeline. Nonetheless, we've logged in, that's all cool. Kind of ruined the surprise by running the Terraform plan, but let's run it again. And it'll come back with exactly the same result, or it should do because we've not applied the plan. Cool, so yeah, we're going to create a resource group, all good. And then to execute the plan, we type Terraform apply. Now again, it will challenge us here to say, are you sure you want to apply it? Because we're creating resources and that could incur a cost potentially. So we want to make sure that we want to do it. So again, it generates the plan and asks us if we want to move forward, and we'll do yes. So that's a good point. The plan command, I can't remember if I've said this, but the plan command is really for us as developers just to check out to see what it's doing. You don't need to actually run that in the sequence that I've shown you there. You need to do the init if you haven't done that already. But once you've done initiation, that's fine. You can then just jump straight to doing apply. Plan is more for us. Cool, and it says the apply is complete. 1 resource has been added, 0 changed, 0 destroyed. So if we come over to Azure, here we are. I'm over in my resource groups already. If we refresh, there we go. Don't know what was happening there. Yeah, TFR main is there. It's probably the least exciting resource to create, but nonetheless, it has been provisioned on Azure for us. Fantastic. Okay, so we now want to create our second resource, which is our container to host our weather API Docker image. Just before we do that, I just want to take you back to Azure and just show you the resource that we're going to create. Just to give you a bit of context, so it's a container instance. I'm not actually going to create it here. I just want to show you some of the attributes that we will be needing to fill in that will become familiar when you actually see it in the code that we write. So what subscription, what's our resource group, that will be the one we created down here, cool. Location, where we are going to get our image from, so we're going to use Docker Hub, and we will specify our image name, which will be something like binary thistle weather API. The OS that we want, the size of our container image, and if we go into networking, we can see that we can say we want it publicly available. We can give it a DNS name, so we can access it from access it in a more friendly way rather than using an IP address, and specify a port. So again, I'm not going to do that here. I just wanted to give you a quick overview of what we're going to create, just to contextualize it for you, but we're going to do it in code. So it won't come as any surprise that we want to create another resource block. And in this case, the first thing we actually need to create is something called a Azure container group. And as before, we need to give it a name. So Terraform container group test, good a name as any. And again, these two things have to be unique within this file. And again, this is not the name of our container that we're going to create. This is just the name of this resource from within this file. So next we do need to specify the name of this container group, and I'm just going to call it Weather API. And we need to specify a location once again. Now we could basically just do what we've done up here and specify Australia East, but one of the nice things about this markup is that you can actually reference other resources, and this is kind of hopefully making it a bit clearer as to what this stuff is. This naming convention allows us to reference this resource from other resources within this file. And if you're used to object-oriented notation, it shouldn't come as any surprise to see that we'll specify the location of this resource. Make sense? Hopefully it does. Fairly straightforward. Just going to tab this out just to make it a bit more readable. Excellent. And then we need to specify the resource group name. I knew I didn't tab that enough. Which we want it to be this resource group here. So again, the whole point of creating a resource group is so we can put this resource into it, and we access it in a very similar way, except this time we specify the name attribute. Cool, now we've got a few other bits and pieces to specify, and I'm just going to copy them across because I'm sure you probably don't want to see me typing that stuff out, and I'm probably going to make a mistake as well. So this should look a bit familiar. Address type public. The DNS name label, we will give it a unique or semi-unique name, binary thistle weather API, and the OS type is Linux. Now the next thing we actually want to specify is a container object. And I'm actually going to copy across these attributes again because they're be a bit laborious for me to be typing these out in great detail. I think you'd probably go a bit crazy. So let me just take you through what they are. The name of our actual container, the image we want to use, the CPU size, the memory size 1 GB, and then the ports that we want to specify. So should look fairly familiar to you from what I just showed you before. Let's save that off. Now let's run Terraform, go into our command window, let's run Terraform Plan and see what Terraform thinks that we need to do in this case. Cool, so it's come back with our plan, and yeah, it's basically saying we need to create this container group resource, and with all the various bits and pieces that we have specified. It has not said that we need to recreate our original resource group for it. So, you know what's coming next? Let's do Terraform apply. And as before, it did rerun our plan again. Let's just enter a value of yes to proceed. Now you can override that with a switch. We can do that later. I'll show you how to do that. Cool. And you can see here it has added one resource, not changed any, and not destroyed any either. Cool, so this is getting a bit exciting now because we're actually provisioned something useful. There we go, Weather API. Click on that and we should have a look and see that it's up and running. Hopefully it is. It's just started obviously, but yes, we've had the option to stop it, so I'm going to assume it's running, and you can see here it's got the friendly DNS name that we provided along with the other things as well. So why don't we test that and see if it's working? So let's copy the URL to the clipboard and let's go back to here and let's just paste, let's just paste the URL in here, making sure we retain the controller that we want to go to. And there we go. So we are out on the interweb with a live container running our application that it pulled from Docker Hub. So very, very cool, very simple, very quick. Now, that's all good, but there was a lot of manual steps there. There was running plans, there was, logging in, all sorts of things like that. So we want to now take this concept, and as per our plan of attack, let me just bring up my beloved PowerPoint. Here we go. Okay, so you've already seen this, so I'm not going to labour it in any more detail. We've kind of done this first bit here. We do still have to do some work on our Terraform file and of course our Azure pipelines file, which is what we're coming on to now. But yes, what we really want to use is Azure DevOps to automate everything we've already done at the command line. So everything else here we've actually done at the command line. So it's now time to move on to Azure DevOps. But just before we do that, what I want to cover off is this little interaction here between Terraform and Azure. We've already done that at the command line, and in order for it to work, I had to issue the AZ command using Azure CLI in order for Terraform to be able to create resources. We don't want that interaction or that interactive login when we come to automating it. So we're going to have to do something about that. And the way we're going to address that is to set up something called a service principal, which is basically almost just like an automated user that Terraform can use to create resources on Azure. So we'll set it up and get it working on our command line to begin with, and then we can use that as the basis to then use it in Azure DevOps. So we're going to go on and do that now. So in order to create a service principal, we need to go over to Azure and create it there, and really just think of a service principal as an automated user, a user account almost, that an application can use to do some things on Azure. So that's basically what it is. It's a system account or an application account, basically. Now, when we set this up on Azure, we're going to get 4 bits of information. We're going to get the client ID. We'll get a client secret, which is basically the password for this user account. We'll get the tenant ID, and that is the ID of our Azure Active Directory that we have created this service principal in, and the subscription ID, which is the ID of my Azure subscription or your Azure subscription. And Terraform you'll configure Terraform so it can use these values to talk to Azure and then authenticate straight through without any interaction. That's basically how this is going to work. So at the command line, we'll set these up as user-defined environment variables specific to me. And then when we come to configuring it in Terraform, we'll configure that in Azure DevOps, and you'll see how we do that in a bit. Before we move on to creating a service principal and obtaining these values, I cannot stress this enough, and I can't stress it enough. I'll probably put flashing red lights up or something. This information, as I'm sure you can understand, is highly sensitive, and if anybody other than yourself gets access to these values, they can absolutely then use your Azure subscription and start creating resources on it, and I'm sure you can understand just how problematic that could be on a whole number of levels. So keep this information under wraps, do not publish it, do not commit it to GitHub or anything like that. And as we flow through this tutorial, we're not going to do any of that stuff. We will keep it secret. So I can't stress that enough. Now I'm going to redact some information on screen, specifically my tenant ID and subscription ID, because that's not going to change for me. I'm not going to tear down my Azure subscription, so I'll keep that kind of secret. The client ID and client secret, I don't mind that being on screen, because at the end of the video I'll tear that stuff down anyway, so it doesn't matter if you have access to it. It won't exist by the time you're watching this video. But yes, absolutely keep it secret from your own perspective. So I think with that, we're ready to move over to Azure and get started. So in order to create a service principal, I'm actually just going to follow the instructions that are provided on the Terraform website. They've actually gone through a number of ways you can authenticate. We've already used this one here using the Azure CLI, but we are now going to configure this one, as we don't want that interaction with the Azure command line when we come to using our CI/CD pipeline. So let's just click on that, and I'm just going to scroll to the bottom. There are a number of steps that we're going to follow. So number 1, create an application in Azure Active Directory. We'll generate a client secret, which again is basically the password for this application, and then we'll grant that application access rights to do stuff on Azure. So again, please be careful with this stuff. It's very powerful. So let's jump over to Azure, and first thing we want to do is create our app registration. So Azure Active Directory, click on that, and then move down to app registrations. And you can see here I already have one I set up for when I was preparing this video, but we're going to create a new one so you can see how you do it. Let's give it a name, call it Terraform Service Principal for CI/CD, something like that. And I'm just going to put a 2 at the end of it, just so I make sure we we know we're going to use this new one I've created, not the old one. Supported account types, single tenant is fine. Let's click register. Now this then takes you into this particular service, this particular app registration. You can see here on screen there's a number of bits of information that I'm actually going to just take a quick note of. So I think I've got a notepad over here. So I've just got a notepad over here with the 4 environment variables that we're going to need, and I'm just going to kind of copy these over to that. So first one, client ID, copy it, paste it over here. Next one is the tenant ID, we need that, paste that in here. Now again, this client ID will destroy it at the end of the day. The tenant ID I've redacted here, or should have redacted it in the edit, which is just the ID of my Active Directory. The client secret we're going to generate next, and we'll get the subscription ID in a little bit. So over to client secrets now, or certificates and secrets. Down in the client secret section, we just want to create a new client secret, and we'll give it a name, Terraform client secret. And you can set an expiration, 1 year's fine, and it provides it down here, so I'll copy that over to my file as well. Now I'm not saving this file, I'm not going to do anything with this file other than use it as a placeholder for these values. We will then plug them into our environment variables in the next step. One comment I'll make about the client secret, if we then revisit this particular section in about 5 minutes time, and you go to try and look at what the client secret is, you won't be able to, Azure actually redacts it, and you can't even copy it, I don't think. So it's that sensitive. They give you 5 minutes grace to copy it in a way like I'm doing here, so you can use it. But then after that, you can't even see it. It's still there, but you can't do anything with it. So it's a security feature, and it's just laboring the point of how important this stuff is. So cool, so we've done steps 1 and 2, create our app registration, created our client secret, and the last thing we want to do is give this application access to Azure Active Directory to do stuff, create resources basically. So let's go home, let's go to our subscription. I'm going to copy this, which is our 4th and final piece of information that I've put over my notepad here. Cool. We then need to go into our subscription, click on that, and we want to select access control. And my screen's running at quite a high magnification level. It's not looking that great. Anyway, we want to click add a role assignment. And we will select a role. There we go, and we want contributor. That gives us enough rights to be able to create stuff. Assign access rights to that is okay. Azure AD, user group, or service principal. You're using a service principal. And then we need to select the app registration we just created. So it's Terraform. Oh, there we go. Terraform service principal for CI/CD 2. Click that. And that kind of puts it down here. It's a bit of a clunky interface, to be honest with you, but nonetheless, it works. So click save, and that should then grant that application rights to create stuff in Active Directory. Awesome, so that's the Active Directory stuff set up from a service principal perspective. We now want to use those values and plug them into our user environment variables so that we can just authenticate straight through from our command line. So I want to test that out now to make sure we've set it up correctly. And what I want to do, just first of all, let me just bring up our project. I'm just going to log out, AZ log out. I think I'm logged out anyway, but I just want to kind of labour the point. So we're logged out anyway, cool. And if we run Terraform Plan, it will fail, cool. So bear that in mind, it will fail. What we want to do now is add these environment variables to our system environment variables. So if in Windows, if you just type env bring these up. We want to add them into our user variables just for me. We don't want to make them system-wide because I don't want, if somebody else logs into this, I don't want them to have access to that. So user variables. Now we can create new ones here, or we can do it at the command line. It's probably a bit quicker to do it at the command line. There's a number of ways you can do it in Windows. Let's just cancel out of that. The command I'm going to use, and I need to make sure I spell it correctly, is SETX. You can probably understand why I'm saying I need to be careful with how I spell that. And then I'm just going to go over to my file here, and I'm just going to issue that command for each of these values here. So let's do the first one, paste it in. Whoop. So I think I need to put, oh, there you go. I think I didn't have a space in there. Let's try that again. setx arm client. Okay, cool. Let me just check that that was added. env environment variables, and yes, we have the arm client there. Cool. All right, so we just need to do that for the other three. So setx. Whoop. I don't know what happened there. Setx, and let me just copy the others across. Client secret. Setx. Okay, cool. So that should be our 4 environment variables set up. User environment variables set up. They are in there. Cool. So theoretically, we should be able to run our Terraform Plan command at our command line, and it should just authenticate straight through. But one thing I would advise you to do, and I'm going to do it here, is just close down your terminal, refresh your terminal. I'm running my terminal within Visual Studio Code, so I'm just going to close that down and restart it. There's probably a way you can refresh your environment variables by running a command. I can't remember what that is. So let me just bring up my Visual Studio Code again. There we go. All right, so I'm in the right project. Yes, cool. I'm just going to do a double Azure logout just to make sure we are definitely logged out at the Azure CLI. Cool, there are no active accounts. So we should theoretically be able to go Terraform Plan. And yeah, cool. It's going to generate our plan for us. So it's picked up those 4 environment variables and it's authenticating straight through. So personally, as a developer, I don't mind using the AZ login interactivity, and in fact, that's what I would use as a developer, just doing my own bits and pieces. Obviously, though, when we come to pushing it into a pipeline, we need this automated method. So I just wanted to check that the groundwork is done, the service principal is set up, so when we come to doing it in the pipeline, we shouldn't have any problems. All right, so with that little bit of pre-groundwork done, we're now ready to move on to Azure DevOps. All right, so moving into some exciting territory now, and we're going to use Azure DevOps. But just before we do that, I always say that, don't I? Just before, this is super quick, I promise you, I want to delete the Docker image that we previously pushed up to Docker Hub, just because we're going to test a push from Azure DevOps, and I want to make sure that it actually does work. So settings, and then delete repository, and I have to type the name in, API, delete, okay. And you know what, I might just delete this as well while we're at it. Settings, delete repository, and it's catalog API. Just so it's super clear, we have no images there. So I have no repositories in my namespace. Perfect. All right, so let's move over to Azure DevOps now. This is Azure. Let's go to Azure DevOps. Does anybody else think that's a rubbish name? Azure DevOps? I find it quite, I don't know. I don't think it's great. I think they could have thought of something better. Anyway, I find it quite confusing. So in Azure DevOps, this is where we're going to set up our automated pipeline. So we need to create a new project. Let's call it Terraform Test 2, as I already have a previous one that I was using to test this video. We need to set it as public, as our Git repository at this point in time is public, if you remember way back when. In advanced, we just set version control to Git, which was what we are using, and work item process agile we're not using, leave it at that. Click create and it will go off and create our project for us. Now, just while it's thinking about that, the next thing we're going to do before we even configure a pipeline is set up a couple of service connections. And a service connection is basically a connection to a service that GitHub, that Azure DevOps will need to use. So thinking back to our diagram, I won't bring it up, it will need to use Docker Hub. We need to push the image to Docker Hub, so it needs access to that. And it actually also needs access to Azure as well. So over in our project settings, let me just step back if you didn't see what I did there. So here we are in our project, down in project settings, click that. On the left-hand side here, you'll see service connections, and we want to create our first service connection. Now I'm running my screen at, let me actually change it to a, I've got it magnified at the moment so you can read the code easier, but I'm going to put it to 100% because I have found that, yeah, that's better. When you're setting up these service connections, you can't quite see all the config properly. So I'll switch it back after I've done this. So the first service connection we want to set up is to a Docker registry. There we go, next. And it will ask you what type of registry. So you could have Azure Container Registry, which we don't want, that costs money, I believe. We want Docker Hub. So we need to tell it how we're connecting. So I'll just enter my credentials. Hopefully I can remember the right one. We click verify. Verification succeeded, and then we need to give it a service connection name. So let's call it, I don't know, Docker Hub. We'll say binary thistle Docker Hub. Cool. Grant access permission to all pipelines. Yeah, why not? No issue with that. So we'll verify and save that service connection. Cool. So we've created a service connection to our Docker Hub. Next one we want to connect to is Azure Resource Manager. So next, we want to select Service Principal Automatic. Next, let's pull back our subscription. We don't need to supply a resource group at this point in time, so let's just call this binary thistle Azure Resource Manager. And grant access to all pipelines. Again, you can call this anything you like. I think I've got a double space in there. Let's take that out and let's save that. Cool. So we've got a service connection for both of those things that we need. Now let me just put my screen back to a lower resolution. Hopefully it doesn't screw up the screen recording. Let's try that. Okay, cool. So we're back to a larger display now. And what are we doing? Where am I? Let's go back to Azure DevOps. Cool. So now what we want to do is create our DevOps pipeline. So click on Pipelines, Create Pipeline. And you'll remember from our diagram, the thing that triggers our pipeline is our code commit to GitHub. So we will select GitHub. And it's going to ask us again to sign in to GitHub. Let me just make sure I get my password in because I have changed it. So yes, it's connected to GitHub and it's brought back a list of our repositories. So the one that we want to work with is the one right at the top here. So let's select that. And what it will do is it will actually bring back a number of suggestions for you as to what it thinks you will want to do with your repository. So it's obviously parsed it and it's seen that we've got a Docker file, so it's kind of suggesting that we want to maybe do some Docker stuff. We do, but the options that we want here aren't shown, so let me do show more. I don't know if the one that we want is in here. I don't think it is. So let's just select Docker anyway. Validate and configure. And this will basically produce our Azure Pipelines YAML file, which is the main file we are going to be working in as we move through the rest of the project. And I'm going to be editing it for the most part in VS Code, and you'll see how that all works in a second. Now, this isn't quite what I wanted. It's put this task in that is going to build our Docker image, which is okay, but that's not quite what I wanted. So let me just put my cursor here. Now, if you've not worked with YAML before, it's white space sensitive. I hate it, to be honest with you. I really don't like it. The editor that, the inline editor that Microsoft have provided here is actually quite good, but you really need to be careful with your spacing and all that kind of stuff. Anyway, what I want to do was add a different task. And if you search for Docker, the one we actually want is this one here, build or push Docker images. Now, we may have the same, probably okay. Actually, let me put the screen back up to a higher resolution, or not higher resolution, demagnify it. I'm giving away all my secrets now. You can see how I set things up. That's better. So what is our container registry? So this is where our service connections came in. And we can see here that the container registry that we want to use is the binary thistle Docker hub. So we select that. And the container repository, a bit of a misleading name, is basically the name of our Docker image that we want to push up. So we'll say binary thistle / weather API. I find, I don't know, like, you know, if you're doing this for the first time and you see container registry, container repository, maybe a wee bit confusing, but nonetheless, that's the values there. Now, this is what I'm talking about. You can just select, once it refreshes, build, push, but we want to build and push. The Docker file is just going to pick up the Docker file from our project. Build context is fine. And the tags, pay a bit of an attention to this. We will make use of this a bit later on. So let's add that here. And you can see it's added another task under our previous task. Now, I'm going to take this out. We don't need this. That's just the previous build step. So I think we can safely take that out. And what we will do is we will copy this task and we will put it up here. Now hopefully that put it in the right place, and I'm hoping that should work okay. So basically, just quickly stepping through it, it sets up some pre-flight checks. It sets up this build ID variable, which will basically is a build number we'll make use of later. Azure DevOps works in a kind of hierarchy, so it starts with stages, then jobs, then steps. So we are defining a build stage here. We will define a separate stage later on, and then it just has some display text. We then have a build job. It defines the virtual machine that we want to perform the build within, and then we can define a number of steps. And we are just going to have one step, which basically goes to our Docker hub, container registry, and will push this repository once it's been built to it. And the command that it's going to issue is build and push. And then there's just some specifications around the Docker file to use and the tag that we want to tag to our repository. So I think we are ready to go. Let's save and run this. We're just going to run it manually from here. We're not triggering it yet from our GitHub repository. Let's just save and run it now. And what it's going to do is it's going to ask to give a commit message and where we want to commit it to. Now we're going to commit it directly into our GitHub repository. So let's save and run that. And it goes away to create the pipeline. And you can then see here that it's starting to kick off. Let me step back into pipelines. I want this view here. Go here. Okay, yep, so it's basically starting our build, it's queued, the agent is waiting to run it basically. So we just have to sit back, relax, maybe grab a coffee, and we'll come back and see how it's doing. It shouldn't take that long, and in fact you can see here it's actually started to build. Now hopefully, all things being equal, we should get a successful build, and it should have built our weather API image and pushed it to Docker Hub. Cool, so I've obviously, you can see how long that took. I've chopped the video just, while it was doing that. I'm sure you didn't want to sit there and watch me watching a screen. So got a little green tick, build was successful. You can dive into the build steps and look and see, if there was any errors or successes. Here it's obviously all gone well, hopefully, so it looks okay. So let me put my screen back to the lower resolution. Most people, this is the feedback I've got from people, that they like it running in this kind of higher, it's not higher resolution, but easier magnified layout. They can see things better, especially when it comes to code, and I do get that, but sometimes I feel it can augment the screen in a way that actually makes it harder to read. But nonetheless, let's try and stick with it. So yeah, that's a bit better. So let's go over to Docker Hub and do a quick refresh. And there we go, our weather API has been pushed up. If you just click on it, I just want to give you a bit of a heads up. There is a tag in here with a particular number, so just bear that in mind, and we can talk about versioning and all that kind of stuff a bit later. But for now, that's pretty good. We've set up an initial pipeline, we have run it manually, we've committed our Azure pipelines YAML file to our GitHub code. In fact, let's just show you that. Let's just go over to GitHub. And if we select let's have a look at my repositories, pick the first one we are working with. Here we are. Horrible looking picture of me there. You will see here Azure Pipelines YAML has actually been added to our repository. Bear that in mind when we come to going back down to VS Code. We will get a little, not an error, but a little message saying we need to synchronize the repository that's on GitHub with our local repository. And from that point in, we will work in VS Code with our Azure Pipelines YAML file. Cool, so we are getting there, but we now need to move on and introduce Terraform into our pipeline so it can actually provision resources on Azure. So let's do that next. So actually, just before we bring Terraform into the mix, I think it's worth triggering our build pipeline from our desktop. So we'll commit a small insignificant code change to GitHub, and that should trigger our build. Now, what I will just remind you of is that the current build version of our image is at 228. So if we trigger another build from our desktop, we should see that change if it's worked correctly. All right, so hopefully that made sense. So back over in our project, let's just let's do a git status just to see where we're at. Okay, so it thinks we, excuse me, we need to add some files to our repository. Now I just really want to add our main.tf. I don't really want to add these files, and I'll come on to what they are in a bit. I don't really want to add them to our repository, so I really should put these into our gitignore file. So let's just do a git add main.tf, git status, and yeah, okay, git commit. Added main.tf, okay, and then we'll do a git push origin master. Now you can see here that there is something rejected. Now basically what that is, it's the fact that we had added our Azure pipelines file to our Git repository, and it's not reflected down here. So I think if we do a git pull, that should rectify it, I think. Okay, maybe it's git pull origin master. We need to do that. Okay, that looks better. Okay, so our Azure Pipelines file has come down. Fantastic. And let's see if we can push it up now. Okay, that's better. Now, I will deal with these files later. We'll leave them there just now. But what we should see if we move over to our pipeline is Let's just do a refresh. Yeah, we can see we have a second build kicking off, and it's going to start running. Excellent. So yeah, basically that part of our pipeline is working okay. We've committed code back up to GitHub, and we've had to pull down our Azure YAML file, Azure Pipelines YAML file, which we can now work on within VS Code. But you can see that it has kicked off our pipeline. Fantastic. So once this is completed, we'll check out our Docker Hub version to make sure it has published a later version, and then we're ready to move on actually to Terraform. Cool, so that looks like that's completed, and again I obviously didn't make you wait to watch that happening. So if we come back over to our Docker Hub repository and hit refresh, there we go. You can see we have a new build version, a new tag of our image, and that will again come in useful or it'll be relevant later. Fantastic. Okay, so now we are truly ready to move on to the next part of our developing a pipeline, and that is adding Terraform into the mix. Okay, so in order to bring Terraform into the mix, you will recall that we want to make use of the service principal that we created in Azure, and in order for Terraform to make use of or use the service principal, it needs access to those environment variables. Now, we previously set those up as user environment variables on our local desktop. We now need to add those into Azure DevOps. Now, the way you do that is making sure you have your pipeline selected, going into library, and then we're going to create something called a variable group. And we can just give it any name we like. I'm going to rename this as Terraform Service Principal bars. And I think that name is fairly self-explanatory. And allow access to all pipelines. Yes, why not? Link secrets from Azure Key Vault as variables. We don't need to do that. So let's add our first variable in. Now I should have my notepad from before. I do indeed. And then after that, I'm going to destroy this notepad. I'm going to, kill it because it has some very sensitive information in there. So the first one is our client ID. And again, please be careful when you add these values in. And again, this just means that we have access to, or Terraform has access to these environment variables when it comes to run. So double check. One, these GUIDs are quite difficult to read, so I'm not expecting you to read the whole thing, but what I usually do is check the last 2 or 3 digits and the first 2 or 3 digits just to make sure they are the same, and I've copied the whole thing. A few times I've not copied the entire thing, and again, it's small stuff like that drives you crazy. And when you find the issue, you've wasted like an hour of your time or something, and it's just not very good. Cool. Now, the one thing we want to do with our client secret is we want to select this little padlock on it, and that just kind of encrypts it. Now, theoretically, we could do that with all of them. There's no reason why not, but let's just do it with that one. In fact, let's do it with our client ID as well, because I think that's somewhat more sensitive. Cool, so that's our environment variable set up. So when Terraform runs within our YAML file and it runs on the agent, it has access to these. Perfect. Now, as I said before, I had this file over here. I never saved it. I am now going to delete it. And don't save it, it's gone. Okay, so again, the client secret and the client ID and the other two as well are actually really sensitive, so please do not have that kicking around anywhere or publishing it out. I'm not going to be held responsible for it, and I won't say anything more about that ever again. I've made that point enough times now. Now, one of the things you'll have noticed actually when we tried to commit our code to GitHub, it mentioned we had 2 files here that hadn't been committed to our repository, and I'll draw your attention to this one here more than anything, Terraform State. Now, what is Terraform State? Well, before we answer that, let's just pop over to my PowerPoint and find the right page. Here we go. So there are a number of files within that Terraform uses. Main.tf, we're already working with that, and as you know, that just holds our configuration code. Terraform vars, we're not making use of a variable file, but basically you can use variables within tf main, and if you want, you can split it out into a separate file, and that probably is good practice, best practice. We're not doing that in this video. We're just going to put them in main.tf for now. And then finally, the file that I really want to talk about is terraform.tfstate. This is a JSON file managed by Terraform, and it's used to map our resources in our main file to our actual running resources in Azure. So it's a way that Terraform keeps track of possibly what it needs to do versus what it has done. So it's quite an important file, and it's used when we apply. Well, it's not quite an important file, it's a very important file, and it is used when we are applying our plan to our provider, in this case Azure. Now, when we run Terraform at our command line, as you can see here, it just creates that tfstate file, and that's all cool. And it needs to persist going forward, so it needs to be there continually. We can't get rid of it. It needs to be there in order for everything to work correctly. Now, that's fine when we are running on our command line, but when we run on our pipeline, the way Azure DevOps pipelines works, and the way most continuous integration platforms work, is when you run your pipeline config, it will provision an agent, run your config, run your plan, and then it will tear that agent down. Now, as part of that, this state file that Terraform needs will be created, sure, but then it will be torn down and it'll be forgotten about. Now, we can't have that situation. We need to persist this state file throughout the use of using Azure DevOps. So we need to store that file off in what Terraform refers to as a backend, so it's persisted, so that when the pipeline runs again the next day, it's available. So that is the next bit of config we're going to do before we actually start using Terraform, to set up some storage on Azure so that we can store our state file there. So let's do that now. Okay, so we want to set up some storage for our state file. Now, I'm actually just going to bring up a notepad because I'm going to make a few notes. I'll just put that off to the side for the moment. So actually, let me just bring it over here. So we need a few bits of information. And we need to create a couple of things for this all to work. So we need a res group or a resource group. We need a storage account. Now, storage account has different types of storage that you can use with it. We are going to use the blob storage account, and as part of that, we'll need to create a container. And then finally, we just need to specify the file name, but we don't do that in Azure. We do that in our main.tf file. And in fact, we actually have to supply all these bits of information to our main.tf file, but we need to create this stuff in Azure. So let's do that now. So the first thing we'll do is create a new resource group. And let's add one, and we will call it Terraform resource group storage. I'll call it blob store. I'm just going to copy that, and I'm going to copy it over to my notepad just so I remember what I called it. Location, we want to put that in Australia East. There we go. And we'll review and create that. Validation passed, create. Fantastic. Now, you might ask, why aren't we using Terraform to do this? Well, we're only doing this once. It's not something we're doing as part of our build pipeline. This is just config. You could potentially add it in if you're maybe setting up development environments and stuff, but it's probably a bit of overkill for us to use it here for what we are doing. So I'm just going to create it manually. Probably have to wait for it to, did it create? Yeah, go to the resource group. Okay, it did create it, cool. Just want to double check that. Sometimes I find that with Azure, it doesn't actually refresh. Yeah, still not showing it there, but I'm fairly sure it has been created. Anyway, it will complain if not. So, okay, we've created our resource group, and the next thing we want to do is actually create a storage account. So into resources, add, and let's just type storage account. And you can see here it has 4 different types: blob, file, table, and queue. We'll be making use of the blob storage stuff. Cool, so let's create that. And the first thing it's going to ask for is a resource group. So you can see here's the one we just created, tfrg blob store. Fantastic. Storage account name, so I'll call it Terraform Storage account. Okay, it obviously needs something really unique, so I'll put my name at the end of it, binary thistle. I'd be very surprised if, 24 characters, okay, so tf, let's take out the account, about that, that's better. Okay, tf storage binary thistle. So yes, you'll have to make sure that is unique. Let me just copy that over to here, paste that in so I have a record of it. Let's set up our location and Australia East. You want standard, account kind, yeah, that's fine. General purpose, replication, we just want LRS, we don't want anything too fancy. Locally redundant storage, and we just want cool, we don't need hot access tier, so we just want something very, very basic. So let's review and create that. I don't know if you can hear that, it's very windy outside here. We're moving into winter here, and which I quite like personally, but it's getting cold and very windy today. So validation passed, click on create. Okay, cool. So it's deploying that, and then we need to do one more thing. We need to create a container for our file, and then we're pretty much set up with this. And then we need to move over to our TF main, our main.tf, sorry, file, and add these details in to configure what Terraform refers to as a backend. Cool, so that has been created. Let's go to our resource. And you can see down here you have different types of, queue service, table service, file service. We are using this blob service. Click on containers, and we want to add a new container. I think of a container almost just like a folder, I guess, I suppose you would say. And we're going to store our Terraform State file in here. And yeah, we want it to be private. I think that's correct. Yep, okay. Any advanced? No, that's cool. All right, let's create that. Cool, so we have a TF state container. Wonderful. So what we want to do now is move back over to our code. And this window here. Cool, I'm just going to get rid of the terminal. We don't need that for the moment. And move back over into our TF main file. Let's revisit that. So we want to basically, as I say, use these details to configure our backend. And so Terraform will then know, rather than using local file storage in this case, it needs to go off to Azure to store the state file. So if you don't mind, I'm just going to, I do have one here, but I do need to update the values. So Terraform, backend Azure, so that's our provider, and then we need to fill these out. These are the values I used for my previous example. Now the one thing we can leave is this key. The key basically just refers to the file name that we want to store. So our resource group, if I bring my notepad back up, was tfrg blob store. And our storage account was this, tf storage binary thistle, and our container name was tf state, wasn't it? Tf state. Let's just double check that. Tf state, fantastic. Okay, cool. Now that's all we need to do there. So that's basically configuring Terraform to use that blob storage to store our state file so it persists throughout multiple runs. Cool, so we'll find out whether that all works or not when we come to actually adding Terraform into our Azure Pipelines YAML file, and we're going to do that now. Okay, so we are getting tantalizingly close to bringing Terraform into our Azure Pipelines file. So back down in VS Code, and let's open up our Azure Pipelines file here. So here we are, this wonderful YAML file. Let me just clear that down. Now, as I said before, Azure DevOps works in a kind of hierarchy of stages, jobs, and steps. So we're now going to add in a new stage to our pipeline. And we need to be really careful, and I can't stress this enough about how you indent. Now, thankfully, Visual Studio Code does provide these, I don't know what you'd call them, lines or something, markers to show you how stuff is indented. Now, I'm going to type this in. I feel that this is kind of the most important part of this video. It's right near the end, and I feel I should type it in as we go and explain it as I go, rather than just cutting and pasting it in. So we want to define a stage. You can call it anything you like, but I'm going to call it provision. And then space display name. And this is just if you actually, when we're running the pipeline and you look at how it's running in Azure Pipelines, this is just what it displays as it's stepping through. So you don't actually have to put this in, but it just helps with fault finding and all that kind of stuff. So we'll say, I don't know, terraforming on Azure. How about that? Then the next thing which is worth doing is this depends on clause. And basically all that's saying is this can't run until, well, whatever we specify here has run, whatever stage we are specifying here, and that is build. So we're saying the provision stage depends on the build stage. If the build stage fails, then there's no point in provisioning anything. Awesome. So we then move into our jobs to specify our jobs. Don't forget the colon. And then we can have any one of a number of jobs, but we're just going to have one job in this case, and we'll call it provision as well. And again, display name. And again, we're graduating down the hierarchy, so we want to put a bit more detail in here. So we'll say provisioning container instance. And then we want to specify an image that we want to use. We do that using the pool directive, and we specify the image here. And let's just copy it from up here, Ubuntu latest. You can specify a version if you want, but I always just go with latest. That seems to work well. And then we want to say, actually we have some environment variables for you here. So we want to specify what those are. Now I actually can't remember what we called our variable group. So let's go back over to Azure Pipelines. And here we are. Now, actually, this is a very good point. I'm glad I did this. You will notice I kind of added these in here. I didn't click save. So make sure you click save. And before we do that, I might actually just change this name. Whoa. Terraform. And just remove some spaces from it. Terraform env vars. Cool. So let's just copy that. This is the value that we need. But let's save it first. I didn't do that. Hopefully it doesn't error out. Hopefully we haven't left it too long. Cool. Let's go back here and see if it saved it. Okay, there we go. Terraform. And I've spelt it wrong. So let me correct that. I always do that. Terraform. Anyway, there we go. Terraform. Okay. Copy that, save it again. That looks like it's saved. Let's go back up a level and just check that it's there. And indeed it is, that's cool. So let's move back over to our file, and we just need to specify that here. But the way we do that is by specifying a group and providing that value there. I absolutely despise YAML. I just need to make sure I have all this in the right place. Cool. All right, so that's our job setup. And then we want to set up a step now. Okay. So steps. And again, we can have more than one step, but let's start with the scripting. Start and end with a scripting step. So this is just a bash script, I believe. And we'll put pipe in there. And then we basically start to define our script, which will make use of Terraform. Okay, so I will make sure I indent correctly and put that under the thing, the R. So we just want to set the E flag, and that just means if we error out, then we come out of this. We don't really continue. Didn't like that. It's trying to auto-correct it, which I don't want. That's incredibly annoying. Let me fix that up in a second. Just put something in here. Maybe because I didn't put, was I putting in the switch? Maybe not. Okay, it's taken that. That was quite annoying. And then basically all we want to do is run our Terraform commands at this point. So Terraform init to initialize the backend, and we will specify the input false flag, equals false. Make sure you say equals false, otherwise we'll have some issues. And all the input false option means is we don't require input at this stage, so it's just Terraform init, fair enough. And then Terraform apply. You'll notice we don't need to run the plan command because it's just a pipeline that's running it. Now again, we'll supply input false, equals false, and also importantly we need to specify auto-approve, which means it doesn't require us to type yes to approve the changes. Now I'm just making sure I've typed that in correctly. Make sure it's equal signs here and a dash there. That tripped me up when I was testing this, and it took me a while to find the issue. It drove me a bit crazy. So cool, that's that done. That looks okay. And then we just really want to make sure I've lined this up correctly, and we want to give the script a name, and I guess call it anything. We'll just call it run Terraform. And then we'll give it another display name. I think it doesn't like the fact there's a space there. Yeah, it can't have a space, so our display name can, of course, run Terraform. Cool. And then finally, we actually have to, in our script, we have to specify the environment variables that we had stored away in our variable group. We have to specify them here so they are actually passed through to Terraform. And we do that by just specifying an end directive, and then we specify our environment variables. Now I'm sure you won't mind, I'm going to copy this over because it would just be way too laborious to watch me typing all that in. And basically we are just specifying the environment variable that we want here, and this is getting passed in from our variable group Terraform envars. That will populate these values here. So again, secure, there's no visibility of what these values are other than going into that environment variable group in Azure DevOps. All right, so there is every chance that I've made some kind of typo in this, but let's run it anyway. Let's be brave and run it and see how we get on. Now, just before we do run it, what I want to do is just clear up all our resources on Azure, take them off. So we've got a clear slate, and remove our image from Docker, again, just to start from an empty playing field. Now, the way I want to remove resources from Azure is to actually use Terraform destroy to get rid of everything, rather than going into Azure and taking all that stuff down manually. So back over in our project, we have a Terraform State file and a Terraform State backup file that we should technically no longer need, because our main.tf file is now making use of Azure backend. So let's get rid of them. Let's delete these from our solution. They shouldn't really, well, so it shouldn't be there. We definitely don't need them. Cool, so I just want to do a quick Terraform init just to initialize our backend. That was all looking good. And then let's do Terraform destroy. And what that will do is it will go off to Azure, look at what's running, and we do have some stuff running that we had set up manually, and it will tell us what it's going to delete. So it's going to say it's going to destroy two things, which is correct, our resource group and our container. And if you want to look in detail, you'll see all the stuff it's going to do. So we'll do yes. So again, great tool for if you're just setting up development environments and tearing them down. I know when I'm preparing for these videos, I'm often having to go into Azure and set things up and take it down. And this is great. Rather than me going in now and manually deleting stuff and possibly deleting the wrong thing, Terraform will just do it for you. So that's cool. And you'll also notice that there's no state file being generated again in our local file system. It's being used, we're using the blob storage up on Azure, which is also cool. Now while it's doing that, let's just pop over to Docker Hub and delete the image over there. So I'll bring over my web browser so you can see what you're doing. We had our image up here. Let us just settings and delete that repository. I'll have to click it first and then it will say weather API. Okay. All right. Cool. So we should have no repositories there. There are no repositories. That was weird. I thought that would have deleted that. It was asking me to sign in. Don't know what's going on with this today. Let's just sign back in. It's still there. Okay. That is very, very weird. I've never seen that before. Let's try this again. Possibly my session timed out or something like that. Don't know. Try it again. That's better. Okay. I think maybe our session timed out or something of that nature. So cool. We have no Docker repositories on our hub. Our resources have been destroyed on Azure, so we have a completely clean slate. So now what we want to do is simply push our new Azure pipelines file up to Git, as well as our edited main.tf file. So let's just do a quick Git status. We can see that, yes, we've deleted these files from our repository. I had actually committed them earlier on just to try and clean it up, so we'll get rid of them anyway, and we have got modified Azure pipelines and main.tf, which is what we want to, invoke our changes basically. So git add. I just always like doing a git status just to see, yeah, cool, and then git commit. Updated pipeline file. Okay, and let's kick this off, and that should trigger a build on Azure DevOps, and hopefully we have some degree of success. So let's go back into our project. No, we won't, because we've not pushed it up to, we've not pushed it up, we've just committed it. So git push origin master. Okay, there we go. That's better. I don't know what I was thinking. I think I'm losing my mind. So yes, we're pushing the repository up to GitHub, and that should trigger a build in a couple of seconds. There we go. Cool. So we'll just sit back, relax, and see how that goes. Grab a cup of coffee and come back when it's done. You'll see here actually that we now have this two-stage build process. So this first little blue blob that's now building is our build of our image, and the second one is the provisioning stage that we added into our new Azure pipelines file. So you know that's taken, that's been pushed up, and it's been taken by Azure DevOps, and it's now working with it. So that's looking positive. And if you click over here, you can just see a nicer view of the two stages, and we'll see how they run. This should still work. We'll keep our fingers crossed for this one and see how we go. All right, so our image has been built. We've got a green tick there. So if we move over to Docker Hub and do a refresh, we should see our image there. And indeed we do. And if we just drill into that while our provisioning step is building, we can have a look and see what's there. So we have our image, and we have it tagged with our new build 236. Cool. So let's see how this provisioning step goes. We can actually drill into it while it's running. Oh dear. So we have some kind of issue on our run Terraform step here. So let's take a quick look in and see what's going on. Check click on this, that's better. Get rid of that. Okay, so we can see here that Terraform has initialized successfully. So that's basically the Terraform init step. Cool. That's all good. And you can see here it's actually started to try and attempt to create our resource group. That looks like that was successful. And then it's moving on to attempting to create our container group, which is going to contain our image, and that's where it errors out. So let's have a look over on Azure and see what's happened there. So let's do a quick refresh. And I'll just remind myself what the name of the resource group we were wanting to create was. The resource group was TF main RG. This is the name here. So I just want to verify that we have that resource group created. We do. So it's kind of half worked, but we've got to the point where we wanted to provision our container and that's failed. Let's have a look a bit more detail at what the error was. Error creating and updating container group weather API. Failure sending request. Original error code. Inaccessible image. The image binary thistle weather API and container group weather API is not accessible. Okay, so I actually know what this is, and it may surprise you to hear, but I did it deliberately just to kind of make a point about versioning our Docker images. So let me just take you through why this has failed, and then we'll fix it up. So yes, as I said, the issue that we're having is all around the way we are tagging or creating or naming our Docker images. So just to review again, the sort of standard convention for people like me or you who are creating Docker images and pushing them up to Docker Hub will be your Docker user ID, so in my case binary thistle, /, and please note there are no spaces there, I've just put spaces in here just to make it very clear. The name of the image, so in our case weather API, and then a colon and a potential version. So in our pipeline, in our Azure Pipelines YAML file, this is what would be getting pushed up to Docker Hub or something like that. I've just put in an actual value of 1, 2, 3, but that would be the build value, the build number, which would change every time we run the pipeline. So that's what our pipelines file, Azure Pipelines file, is creating, and we saw that just in the last step. Docker image has been pushed up with a build number. In our Terraform main.tf file, we are specifying that we want Azure to build a container with the name of this image here, okay? We're not specifying any value. And when that request goes to Azure, Azure interprets it as this. And we'll actually pop over to Azure and have a quick look at what I'm meaning there. If you don't supply an actual value that you want for the version, then it will just default to this latest version. And as a result, it will throw an error. Now, the one question you might have was, we actually used Terraform in its current form, the main.tf file, to provision resources on Azure, and it all worked. How did that work? Well, it worked because when I ran Terraform at the command line, I had previously pushed a Docker image up to GitHub, not to GitHub, up to Docker Hub without specifying a number. And so basically, if you can maybe recall, you can even wind back the video, you would see that in the versioning list, there was actually a latest version. So that's why, in that instance, it succeeded when we manually did it all, because I didn't specify a value at the command line when I pushed the Docker image up. And now it's throwing an error. So yes, there we go, we manually pushed, when we manually pushed, we didn't specify a version, and it actually worked. Okay, so let me just pop over to Azure and I'll just quickly show you what I'm talking about. Okay, so let's pretend we're going to create a new container instance resource. So I'm going to create a resource group, didn't want to do that, come back out of that, go home to resources. My apologies. So let's pretend we're going to add a new container instance. We're not actually going to, I just want to show you, just to be super clear what's happening. Let's go create. And if we scroll down and select Docker Hub as the registry that we want, what you can see here, if not specified, Docker Hub will be used, fine, for the container registry, and the latest version of the image will be pulled. So basically what's happening is the only image that exists on Docker Hub is specifically tagged with a version number, and when we try to create the default, which is using latest, it fails. So hopefully that makes sense. So how do we rectify that? Let's go back to the PowerPoint. How do we rectify that? So my initial go-to response was, well, in our Azure Pipelines file, why don't we just take this value out? Why don't we just not specify the build value? And I'll just show you where that actually happens, just again to be clear, so you know where it's happening. So in our Azure Pipelines file, in our build step, we apply this tag to the image here, and that tag is basically the build number. Okay, so that's where that's coming from. So I thought initially, why don't we just get rid of that? Don't bother tagging the image. And that means the image that we push up to Docker Hub will be this latest image. It won't actually have a build number, and it would all work. Sounds like an acceptable solution, but it won't work. Why won't it work? Well, this is a bit of an interesting concept if you've not heard it before. Terraform generally, and the Terraform apply command is what we call idempotent. Be careful how you pronounce that. What does that mean? Well, idempotence is a concept in mathematics and computer science, and basically, very simply, it means when we perform the same operation again, we will get the same result. So Terraform apply is idempotent. Now what does that mean? Well, if we didn't specify a build version in our Azure Pipelines file and we just pushed up an image to Docker Hub that was tagged as latest, the first time we run our pipeline, everything will work as expected, because what will happen is our image will get pushed up to Docker Hub, Terraform will run, it will say we want to provision a container with this name, which would just be binary thistle weather API, cool, and that would all work perfectly. However, we then make some changes to our code, we rerun our CI/CD pipeline. What will happen is every time after, Terraform will look and go, has anything changed? Now, from a Terraform perspective, all it's looking at is the plan that it needs to create. And in the plan, nothing has changed. It's not really aware that code has changed. It's just aware of the plan that it's been given. And according to the plan, nothing has changed. And so nothing will happen. It won't actually deploy a new image down to Azure. So that's where idempotency comes in. You could run it again and again and nothing will change, because as far as Terraform is concerned, it's the same operation. So specifying a build number will actually remedy this. So what we'll do next to finish this whole thing off and rectify our issue is we'll leave our Azure Pipelines file as is and still tag it with an image, but what we'll do is we will pass that tag through, that build number tag through, into our TF main file, and that means every time it runs, when Terraform looks at its, what it has to do, because it's got a new build number every time it runs, it will go, something has changed, I actually need to do something. And the idempotency clause or principle does not kick in. And we then get our code flushed down to Azure. So hopefully that made sense. Let's put versioning into our main.tf file, and we'll rerun our pipeline, and we'll even do some code changes to make sure they actually get flushed down, and we'll see how we go. Okay, so what we want to do is back over in our Azure Pipelines file, we want to kind of replicate what we're doing with our build image and pass that tag value through to Terraform so it can use it. And number one, it will resolve the issue we're currently having with our pipeline, and it will also solve an issue we would have potentially had in the future had we just reverted to using the latest image. So let's do that now. Now, the way you do that is by providing a user-defined environment variable through to Terraform. Now, they are all, if you're using Terraform variables, they're all prefixed with tf_var_, and then you just give the variable the name that you want. Now, we can call it anything we like. Let's call it image build. Seems as good a tag as any. And what is the value? We simply just pass over this tag value here that's defined further up in our Azure Pipelines file, which is just getting the build ID. So from Azure Pipelines perspective, that's all we need to do. We just need to introduce this new custom environment variable and pass over the tag value. We then move over to our main.tf file. Now, what we really want to do is here, when we're requesting the creation of our container, we want to basically have that value here somewhere and put a variable in here. And you won't be surprised to hear that the way we do that is by actually declaring a variable in our main.tf file. And you may recall I was talking about there are different types of file in Terraform, so our main.tf, our state file, and you can also push out your variables. If you've got a lot of them, you can push them out into a separate variables file. We're only going to create one variable here, so I don't think we need to do that. So we're just going to create our variable within our main file. And so the way you do that, you just basically declare a variable, give it a name. Now this is important. Name is going to be just this section of the environment variable that you defined, not the whole thing, just the bit after the second underscore. Which I found, I don't know, I had to, even though this is all documented, I just found this bit, I had to play around with it a bit before I got it to work. I put the full thing initially and it didn't like that. So anyway, just my little complaint. So that's the variable that you declare. We don't give it a default value. That value will be passed in from Azure Pipelines. And we can give it a description, latest build, image build. Fingers aren't working now. Okay. And then all we need to do is just append it into here in our image name, just so it takes on a new build number every time. And the way you do that is $, curly brackets. You got to specify a var, dot, and then you just give it the name of your variable here. So that's the same pattern you can use time and time again. You can pass over, custom environment variables from your command line or from your Azure Pipelines file. They will get passed in here. You have to declare a variable up here, and then you can just use your variables within your creation of your resources. So it gives this degree of flexibility, which is very, very nice. And best practice would typically be to pull these variables out into a separate file. If you had maybe more than one of them. We just have one. I think it would be a bit of overkill to do that. So I think that all looks pretty good. Hopefully that makes sense to everybody. So when we request the creation of the container, we're going to be asking for the specific build version, and everything should work okay. So I think all that's left to do is to commit this code back up to GitHub and rerun our pipeline and see how we go. All right, so let's bring up a command window terminal. And let's just look at our git status to see what, actually before we do that, the one thing I do want to do, and I said we would do it, I'm glad I remembered, is let's update our weather controller. So this was the I guess you'd call it weather descriptors that comes out the box with it. Let's change that to something else, just to test that we're actually getting the new code flushed through as well. So I'm not going to type this in because it'd be very boring to watch me do it, and all I'm going to do is just basically, because this data is somewhat randomized, we don't necessarily know which one of these we're going to get when it runs. I'm just going to replace all of these with XXX's. Okay, so we should see XXX when we run our API if this all works. Cool. So let's do a git status. And yep, our 3 files have changed. So we have changed our controller, we've changed our Azure Pipelines YAML, and we've changed our main.tf. Now again, this is a great demonstration of code being deployed as a unit. So we get some infrastructure code, we've got a pipeline code, and we've got an actual application code all being deployed up to GitHub at the same time. Awesome. So let's do a git add everything. Let's do a git commit. Fixed our pipeline, and that's all good. Git status, our local branch should be clean. It is. So let's do a git push origin master to kick off our build on Azure DevOps, and we'll see how we go. Hopefully this time we have some success. So let's move over there now, back over to Azure Pipelines. Let's click on Pipelines. I think that's already kicked off. There we go. So here's our second build coming through. So we just have to sit back patiently with our fingers crossed and see how we go on. Okay, so our push to Docker Hub has worked. Let's step into our provisioning step. I'm fairly confident if we move over to Docker Hub that will be okay. I'm going to leave that off the screen just so we can see what's going on here. Here we go. Okay, job finished initializing. We're running Terraform now. Let's see how it goes. Initialize the backend, initializing the provider plugins, cool. And we should start to see our resources being created. Last time we did get as far as the resource group, that was created okay. And now potentially because we already had a resource group there, it shouldn't recreate it. It should just know that it was already there based on the state file, so that's cool. So it looks like it's now going into creating our container group. This is a very good sign because we're seeing this 10 seconds elapsed, which basically means it's kicked off, it's starting to provision it, and it's just waiting for Azure to finish doing that. So I'm fairly confident that this has worked well. So we just need to let this do its thing, let it run, and then we will quickly test our API in Firefox and have a look at the payload and make sure that the new code has been flushed through. Look at that. All green, all clean. There is nothing, in my view, nicer than double green dots on something like a build pipeline. It's one of the most satisfying sights to behold. So that all looks good. Let me just remind myself what we called our container image. Let's go back to our main.tf file. We called it Weather API. So let's go over to Azure to make sure it's being created. I'm fairly confident it has been. Let's go to all resources. I don't want to do anything with that. Let's restore this, or refresh it, should I say. There we go. Weather API has been created. And it all looks like it's up and running okay. So let's copy the URL and pop over to Firefox and type it in here. And don't forget to call the controller weather forecast, wasn't it? And there we go. It's up and running, and as you can see, the summary has been replaced with all X's, so our code has been flushed through. Now, the real way to double test it would be to, and I'm not going to do this, I'm fairly confident it's going to work, but we would go back into our weather forecast file, change this back to the way we had it, don't change anything else, rerun our pipeline, push back up to GitHub, rerun our pipeline, and I'm absolutely 100% confident that change will be flushed through. So we go over the idempotency issue, and we also fix up our pipeline as well. With that, I think I don't have much else to go through. I'm just going to move on to our final bit of wrap up. I've got a bit of homework for you, a couple of improvements you could possibly make to this, but let's do that next. Okay, so I wasn't joking when I said I had homework for you, and now I know that for those of you who have left school many years ago and college many years ago, you'll be quite surprised that some random dude on the internet is giving you homework. But you know, life is weird like that, isn't it? And I do expect it on my desk first thing Monday morning, no excuses. All joking aside though, I do have a couple of things that I think could be improved. Well, there's probably more than a couple of things, but a couple of things spring to my mind are a couple of questions I have are, will running Terraform at the command line, will that work now? And if not, how would you fix it? And then the other one is our image name, binary thistle / weather API, is kind of hard coded in two separate places, in Azure pipelines file and also in our main.tf file or Terraform file. Is this a good approach? Could it be improved? I'll leave that with you. Other than that, all I have to say is thank you once again for watching. If you liked the video, give it a like. If you want to see more of the same stuff, why don't you subscribe if you've not done already, and you'll be notified when I post some new stuff up. And to my wonderful followers on Patreon, again, thank you so much for the little bit of extra support that you give me. I really appreciate it. And your names are going to be coming up next. Other than that, to you all, stay safe, stay happy and well, and I will see you again next time.